there's sort of two ways that I like to think about that question. One is it could be that the Big Bang was an interesting event, but not the first event in the totality of reality. It could have been the first event that sparked the expansion of our part of space. But it could be that there's a grander realm of space within which we sit as a small part, and that grander realm may have been there for a far longer period of time. It may have experienced its own Big Bangs, maybe a collection of Big Bangs that may extend infinitely far into the past. So it could be that the answer to the question of what happened before the Big Bang is a lot of other Big Bangs or a lot of other quantum events that were taking place in a larger landscape of reality than we have direct access to. However, another answer is that the very question may not make as much sense as the words seem to suggest. We know how to parse that sentence. We know what it means to talk about the moment before the Big Bang because we know how to talk about the moment before your birth or the moment before the Civil War or the moment before any event that happened in the world. We fully understand the meaning of that kind of sentence. But it could be that when it comes to the Big Bang, the sentence actually doesn't mean anything. It could be that the Big Bang was the place where time itself started. And Hawking himself had a wonderful analogy to get this across. He said, look, I'll dress it up a little bit. Imagine you're walking on planet Earth and you pass by someone. You say, hey, can you point me in the direction of north? I want to walk in the northward direction. They point you, continue to walk. You pass by somebody else, say, hey, which way is further north? And they point you in that direction. But when you get to the North Pole and talk to somebody there and say, hey, how do I go further north? They look at you and say, whoa, that question doesn't mean anything because this is where north begins. There's no notion of going further north than the North Pole. And it could be that that spatial metaphor applies to time. Talk about 1 billion years ago or 10 billion years ago, but if you go to 13.8 billion years ago, the Big Bang, that may be where time started. And you can't go further back in time than the very origin of time itself.
That freaks me out.
Yeah.
See, that's one that it gets in your head and you go, what do you mean beginning of time?
Yeah.
Why would time have a beginning?
Good. And it could be that time is an emergent quality of reality. I give you an analogy, boy. What I mean by that is we all know what temperature means intuitively. Something's hot, you feel it. Something's cold, you feel it. Your body understands those concepts. What physics has done is it's gone deeper into the concept of temperature and revealed that it is nothing but the average motion of the particles making up the environment. So if the molecules are moving really quickly, you've got a hot environment. If the molecules are really moving slowly, it's a cold environment. So temperature emerges from the motion of particles. So if you have like one particle, you can't really talk about it being hot or cold because you need a conglomerate. You need an agglomeration of particles to be able to talk about their average motion. And in that sense, temperature is this emergent idea that rests upon more fundamental ideas, the molecules and atoms that make up reality. Maybe that's true of time. Maybe time as we know it is a property that only makes sense in certain environments when there's enough stuff arranged in the right patterns. But fundamentally, maybe there are atoms or molecules of time which, when not arranged in the form that we are familiar with, don't yield time as we know it. Time itself may be a quality of the world that exists here in this environment, but doesn't even apply in other environments that are configured radically differently.
Whoa. That's a heavy one.
Yeah.
That's a heavy one. What also is a heavy one is what caused the Big Bang?
Yeah.
Like, why would something smaller than the head of a pin become everything that we see in the cosmos?
Yeah. So there are ideas for the answer to that question. Look, all of this is tentative because it's very hard to do measurements that go all the way back to the beginning. We have astronomical observations that we need to be sure are compatible with the predictions of our theories and so forth. So we as good scientists do what needs to be done to try to test these ideas. But the idea that I think most physicists or cosmologists buy into at the moment is that gravity can have two manifestations. The usual form of gravity that you and I know about is the attractive version. You drop something toward the Earth and it moves downward because the Earth and the object pull on each other. That's the ordinary gravity that we experience every day of our lives. But Einstein's equations actually allow gravity to also be repulsive. It can push outward as opposed to just pulling inward. And this is something that we have never experienced because the gravity created by a rocky object like the Earth is always the attractive variety. The gravity created by the sun, again, a compact object, is always the attractive variety. But Einstein's math shows that if you don't have a rocky object that's isolated in space, but rather energy that is uniformly spread through a region of space, that kind of entity yields repulsive gravity. Why is that important to your question? If the very early universe, that little tiny head of a pin that you're talking about, if it was filled with a uniform bath of this energy, we call it the inflaton field, the name doesn't matter, but if it was filled with that energy, it would have been subject to repulsive gravity. What does repulsive gravity do? Pushes everything apart, causes everything to rush outward. So the bang of the Big Bang may have been a spark of repulsive gravity operating with a tiny region of space that pushed everything apart.
And this concept of repulsive gravity is just theoretical? Have we observed any sort of element in the